What does this mean for phase transitions? For a phase change, this point clearly depends on the temperature. Delta G is delta H minus T delta S. So as I change the temperature, delta G could be positive, could be negative, or there is a temperature at which it is 0. We can solve for this temperature by setting delta G equal to 0, and then we know that delta H has to equal T delta S. So if we know the enthalpy of the transition and we know the entropy of the transition, we can determine the temperature at which the transition occurs. That allows us to make lots of comparisons between different liquids, say, for where their boiling temperature is. If you remember, we said delta S was the same for almost all substances for vaporization. So that means the delta S isn't really changing substance to substance. Delta H, on the other hand, is. Delta H was the one that depended on the intermolecular forces. Those depended upon what the actual molecule is. Does it have a dipole, hydrogen bonding? Does it have big dispersion forces, small dispersion forces? So if we know the magnitude of delta H, we can know something about that temperature T. If the intermolecular forces are larger, delta H will be larger, and then the temperature will be larger. That is, the temperature will be a higher value. And so strong intermolecular forces will lead to higher boiling points. What have we learned? Okay, differences in enthalpies of vaporization for different compounds depend on their intermolecular forces. Differences in enthalpy are really differences in static or in potential energy due to electrostatics, the attractions between the molecules. In the liquid, they're next to each other, they're close by, they're low in energy. In the gas, they're far apart, they're higher in energy. Stronger intermolecular forces mean larger enthalpies of vaporization because the difference between the liquid and the vapor will be bigger. Entropies of vaporization are very similar for most compounds. And so if we look at equilibrium, where delta G is equal to 0, delta H is equal to T delta S, and putting this all together, if delta S is the same for most things, the higher delta H is, the higher T will be. Stronger intermolecular forces, stronger and bigger enthalpy of vaporization, higher phase transition temperature, which is higher boiling point.